Welcome to this module of Professor Messer's free CompTIA A+ certification training course on identifying memory types. I'm James Messer. In this module, we're going to step through the requirements of CompTIA A+ 220-701, Section 1.6. So this is our essentials exam that says that we need to compare and contrast memory types, characteristics, and their purpose. And specifically for this module, we're going to look at memory types. There's a lot to know. There's a little bit of math involved, but it's not too bad. As long as you memorize one single formula, you should be pretty good if you get any questions on your exam dealing with the amount of throughput that you would get of different memory types. Let's start with an overview of different memory types and some of the things that you would expect to see when you look at a computer or some of the things that you'll see on your exam. Before we go into the details of all these different memory types, it's worth mentioning what is memory, because very often the term memory is used in replace of something else. Sometimes people say, how much memory space does your disk have? Well, disk doesn't have memory space per se. There is an amount of space on a disk where it stores information. We're talking about the memory chips. We're talking about the silicon inside this computer, chips that generally don't look too much like our picture anymore. These are some older types of memory. We're talking about either random access memory, which is generally when we say how much memory does your computer have, that's what we're talking about. It's not the only kind of memory you'll run into, but this is really the memory doing most of the work inside of your computer. So obviously if we want to do more, we want to work with audio, we want to work with video, we want to do other things, this is the type of memory we will need. When we do a memory upgrade, we are upgrading your random access memory. And as I mentioned, your memory has nothing to do with hard drive storage. Hard drive storage is a different amount of information. We cannot run programs from your hard drive. For a program to execute, it has to be in memory, or that data that we're looking for has to be in memory. Some people will mix those terms. Be careful not to do that. We'll also talk about the data on your hard drive as something that's stored permanently, whereas generally when you turn off your computer, the random access memory in your computer needs constant refreshing to be able to maintain what's in the memory. When we turn the power off, that obviously is not refreshed any longer, and the memory completely dies. It doesn't store that information, whereas the information in your hard drive, obviously, if you're storing data there, you turn your computer back on, it's still going to be there and available for you. As I mentioned, you can only use that data or execute those programs if they are in memory. Sometimes you'll hear people talking about swapping information out to disk, using your swap drive or caching that information to disk, which is great. What that means is that we're not currently using that information. We don't need to execute that part of the program. We don't need to use that data. We're going to store it on disk right now and free up more of our random access memory that we can use to execute programs and to calculate different types of data. If it turns out we need to calculate or execute something that we've swapped out to disk, we have to pull it back off of disk, put it back into our random access memory to be able to do that. So if it's on disk, we can't execute it. If it's in memory, we can do whatever we would like to that. And so just keep that in mind. That's why whenever we're talking about your computer needs more memory, that's why we need to put more information into that random access memory and be able to execute or calculate that information. And the only way to do that is we have enough room there to be able to put all of that in there at one time. Another type of memory you'll see very often is read-only memory. This is memory we don't often reference. It's usually something that, as the name implies, is written to once. Sometimes there are types of read-only memory that can be erased. It's not really read-only memory at that point. We'll talk about that in a moment. This is where normally you'd see our BIOS. This is a BIOS chip in one of my older motherboards on my computer. It's read-only memory. I can't change what's on there. When we power off our computer, it actually does not lose what's in that memory. It is very static in the way that it's operating, and whenever we turn our computer on, it's always going to be there and available. In fact, that's pretty important for your BIOS, because you want that whenever you turn your power on, that computer needs to be able to know what to do. And as long as that memory is in my computer and it has all the information I need, it will be able to do that. The way that you program these and the type of memory you can see that you might be able to program in the field is something called PROM, or programmable read-only memory. Most of this PROM memory is something where you're getting a piece of memory like this chip, and you are programming it with a very specialized device. And once you've programmed it, that's it. You can only write to it one time, and you can't write to it any longer. There is a type of read-only memory that is an erasable programmable read-only memory, where you're able to write it, You can run it a little bit. Maybe you'd like to make a change. You pull that memory out, put it back in your programming device. You reprogram that, put it back into your computer. Now you've updated that. That type of erasable, programmable, read-only memory, very similar to the flash memory that we have in our computer. It's a little bit different format and a different context in the way that it's used when you see the word EEPROM, but it is a type of functionality where I can keep reprogramming and reprogramming that chip whenever I'd like. There is this electrically erasable, programmable, read-only memory, which really is a more appropriate way to think of our flash memory, where I'm not using a separate device to program it. I can program it right in my computer. It's all done electrically, and these days on our most common computers where we need to update the BIOS of our computers, it's updating it using this electrically erasable, programmable, read-only memory. Now that we've looked at random access memory and read-only memory, let's look at differences between static memory, static random access memory, and dynamic random access memory. Static random access memory is exactly like it sounds. When we put information into this memory, it's static. It's there now, and we don't have to worry about it going anywhere. If we power off our computer and power back on, it's static. It's also very fast memory. It's memory that very often is, because it is so fast, it is also very expensive. And if you're wondering, why don't we just use static memory for everything? There's two really good reasons why. Here's another. It takes up a lot of room. It's all relative these days. We want our devices to be smaller and smaller and smaller. Static memory is a little bit bigger than what we're dealing with in dynamic memory, which we'll look at in a moment. It's very green memory in that it doesn't need a lot of power to be able to operate. In fact, very little, in some cases, no power. We only have, when you're ready to change it, you apply some power to it, and then it sits there. You don't have to keep constantly refreshing that memory again. We usually see static RAM in our computers these days in a cache memory associated with the motherboard on the chip itself, on the CPU chip itself, because it is so fast and it's able to work very, very quickly. We have it in these processor caches. And that's why we don't put it everywhere else, because it is relatively expensive to have this type of memory, and we use it in small chunks on our computer. It's not something we can really apply to the rest of our systems, and at least not apply it that way and keep the prices down to something that we could appreciate. Instead, we're using dynamic random access memory. I've got some very old dynamic random access memory here, but we're going to look at other pictures of dynamic RAM whenever we start going through the rest of this presentation. Whenever we're talking about upgrading our computers, we're talking about the total amount of memory inside of system. This is what we're talking about. It is dynamic, and as the name implies, has to constantly refresh. We have to constantly give this power in order to keep the information within memory where it is. If we stop refreshing this memory, the data just disappears. It's not there anymore. It's not able to keep the state that it has. So whenever I'm doing that memory upgrade, I'm getting the dynamic RAM to be able to do that. And you'll see the word DRAM, DRAM, dynamic RAM on the package of the memory upgrade that you're doing. Most often, you're actually seeing the word SDRAM, synchronous dynamic random access memory, which is a really more appropriate way of explaining the type of memory that we have inside of our computers. So SDRAM, it's very similar in the naming and the abbreviation to SRAM, but don't confuse the SDRAM with static RAM. This is synchronous dynamic, not static. So it's a very different kind of memory. Don't confuse those two. When we talk about the S in synchronous, that means that this memory is synchronized with the clock that's keeping track of everything on this memory bus. It matches it exactly. And on our very fast computers, this is a great way that we can make sure that the different chips and the different components inside of our computer have a very common way of when they can expect data to come across that bus. And if there's a clock that's keeping time, it's almost like everybody's rowing at the same time, then you happen to know exactly when you would put that oar in the water and exactly when you should be pulling. It's the same thing. There's a common clock, and every component knows exactly when a type of piece of data should be coming down that bus, and everybody is synchronized. And so the synchronous dynamic random access memory is designed to work in exactly that type of environment. You'll see it abbreviated sometimes. If this is a bus that is a 133 megahertz clock, everything on that bus is synchronized to that clock rate. You may see the memory abbreviated as a PC133. We're dealing with this very generic synchronous dynamic RAM. So don't be thrown by the PC133. That's really referring to the clock rate that's on that bus.